Case 1. Division of monomial by a monomial. Quotient of two monomials is equal to quotient of their numerical coefficients into quotient of their literal coefficients. Let's see an example. Example is divide 32a cube b cube by minus 8ab. The solution is 32a cube b cube by minus 8ab is equal to, first we will divide the numerical coefficients, that is 32 divided by minus 8, and then we will divide the literal coefficients, that is a cube b cube by ab. We will multiply both and get the final answer as minus 4a square b square. Case 2. Division of a polynomial by a monomial. Here what we'll do is divide each term of the polynomial by the monomial. Let's see an example. 3 by 4 ab square c cube minus 2 by 5 a square b square c square plus 1 by 3 ab square c by half abc. So here what we'll do is we will divide each term of the polynomial by half abc. Doing this we will get 3 by 4 ab square c cube by half abc minus 2 by 5 a square b square c square by half abc plus 1 by 3 ab square c by half abc. On simplifying this and solving each term individually, we get 3 by 2 bc square minus 4 by 5 abc plus 2 by 3b. Case 3. Division of a polynomial by a polynomial. Let's look at the method of division of a polynomial by a polynomial. First, set up as a form of long division in which both the divisor and dividend are arranged in descending order, leaving space for missing terms. Second, divide the first term of the dividend by the first term of the divisor and write it as the first term of the quotient. Third, multiply the first term of the quotient by each term of the divisor and write the product below the dividend. Fourth, subtract like terms and bring down one or more terms as needed. Fifth, now use the remainder as the new dividend and repeat steps 2 to 4. Sixth, repeat this process till we get the remainder either equal to 0 or a polynomial of degree lower than that of divisor. Let's take an example. Divide x cube minus 4x square plus 7x minus 2 by x minus 2. Let's solve this. In this question, taking x cube minus 4x square plus 7x minus 2 as dividend and x minus 2 as divisor. In the quotient, first we take x square. X square is multiplied with x minus 2 and we get x cube minus 2x square. Changing the signs, x cube gets cancelled with minus x cube. Minus 4x square plus 2x square is minus 2x square. Copying 7x from above. Now we'll take minus 2x in quotient. Minus 2x gets multiplied with x minus 2. We get minus 2x square plus 4x. Changing the signs. Minus 2x square gets cancelled with plus 2x square. 7x minus 4x is equal to 3x. Copying minus 2 from above. And in the quotient writing plus 3. 3 gets multiplied with x minus 2. We get 3x minus 6. Changing the signs. 3x gets cancelled with minus 3x. And minus 2 plus 6 is 4. Therefore, for x cube minus 4x square plus 7x minus 2 divided by x minus 2, we have quotient equal to x square minus 2x plus 3 and remainder is equal to 4. In case of algebraic expressions also, we can check by using the division algorithm. Dividend is equal to divisor into quotient plus remainder. In this question, we have divisor is equal to x minus 2, quotient is equal to x square minus 2x plus 3, remainder is equal to 4. Divisor into quotient plus remainder is equal to x minus 2 into x square minus 2x plus 3 plus 4 is equal to x into x square minus 2x plus 3 minus 2 into x square minus 2x plus 3 plus 4. Opening the brackets, this becomes equal to x cubed minus 2x square plus 3x minus 2x square plus 4x minus 6 plus 4. On simplification, this becomes equal to x cubed minus 4x square plus 7x minus 2, which is equal to dividend. So here we are getting dividend is equal to divisor into quotient plus remainder. That means the division we have performed is correct. Let's take one more example. Divide 8x cubed minus 27 by 2x minus 3. Let's solve this. Here we will leave space for missing terms and take the dividend as 8x cubed, leaving some space, then we'll write minus 27 and divisor is 2x minus 3. We'll start with 4x square. 4x square gets multiplied with 2x minus 3. We get 8x cubed minus 12x square. Changing the signs, 8x cubed gets cancelled with minus 8x cubed. And changing the sign of minus 12x square, we have 12x square. Next in quotient we write plus 6x. 6x gets multiplied with 2x minus 3 and we get 12x square minus 18x. Changing the signs, 12x square gets cancelled with minus 12x square and minus 18x on changing the sign becomes 18x. Bringing down minus 27. Now in the quotient we write plus 9. 9 gets multiplied with 2x minus 3. We get 18x minus 27. On changing the signs, 18x gets cancelled with minus 18x and minus 27 gets cancelled with plus 27. The remainder becomes 0. Therefore, 8x cubed minus 27 divided by 2x minus 3 is equal to 4x square plus 6x plus 9. Let us do an example. Our example is find whether 4z square minus 5 is a factor of 4z to the power 4 plus 7z square plus 15 or not. Let us see the solution. For checking the factor, we will divide 4z to the power 4 plus 7z square plus 15 by 4z square minus 5. If the remainder comes out to be 0, then 4z square minus 5 is a factor of 4z to the power 4 plus 7z square plus 15. Let's perform the long division. Taking 4z to the power 4 plus 7z square plus 15 as dividend, and divisor will be 4z square minus 5. Initially, we will start with z square, so writing z square in the place of quotient, multiplying z square with 4z square minus 5, we will get 4z to the power 4 minus 5z square. Changing the signs, 4z to the power 4 will cancel with 4z to the power 4. 7z square plus 5z square will be 12z square. Copying 15 from above. Now in quotient's place we will write plus 3. Multiplying plus 3 with 4z square minus 5, we get 12z square minus 15. Changing the signs, 12z square gets cancelled with minus 12z square and 15 plus 15 is equal to 30. Therefore, we get a remainder of 30 here. Since the remainder is not 0, so 4z square minus 5 is not a factor of 4z to the power 4 plus 7z square plus 15.